Really excited to be here and do this workshop. I'm very thankful to Ava for hosting it. So a little bit about myself and Decentology. So I'm the co-founder and CEO of Decentology, and we are a platform that is developer-centric. What we do is we make it super simple for developers to build blockchain applications. Our product is called DappStarter. And in today's workshop, it's basically going to be a walkthrough of dAppStarter and how to build with it. So with that out of the way, let me start sharing my screen so we can look at some of this information. And I'll be telling you more about our product and how it works as we go along. But before we get started, I'm at TechBubble on Twitter. If you want to follow me, that would be great. I do tweet a lot about tips, especially directed towards Web2 developers who are transitioning into Web3. And so you might find those useful. All right, so let's see what dAppStarter is all about. So if you go to our website, you should find a link there, or you can go directly to dappstarter.decentology.com. And what you're going to find there is the main dAppStarter UI. So we are blockchain agnostic, and we support multiple blockchains. Of course, today we are here to talk about Avalanche. So the first choice as a developer you make when you're going to use dAppStarter is the blockchain. And typically we'll support the primary language for a blockchain. In this case, Avalanche is EVM compatible, so it's Solidity. You then choose a framework, and you can choose Vanilla.js or React. We're going to do work with Vanilla.js today. And then our primary value proposition, in addition to some of the orchestration, et cetera, you'll see, is that we have taken common design patterns that are prevalent in blockchain decentralized applications, and we have abstracted them into these modules. And so as a developer, what you do here is you choose different modules in any combination you wish, but probably that makes some logical sense. And once you do that, what we will do is we will create a custom GitHub repository for you with all the source code for it. And that's what you're about to see. So I can talk about this, or I can show you. And I love to show things because it's much more fun. So what I'm going to do here is first choose the contract run state module. I love to use this module because it's a very simple module. It allows me to demonstrate dAppStarter without having a lot of complexity. It's basically the ability to pause and unpause a contract, a feature you want if you've got a contract, especially one that handles money, where if there's a problem, you want to like put the brakes on things until you sort things out. So we'll choose that one. We've got the usual tokens, etc. Another one that I'd like to add today is one called custom NFT. NFTs are hot right now, and we implement the 1155 spec for you. And we can use that by checking this box here. We've got a couple of options. We'll choose collectible here. And we've got IPFS integration, that's decentralized storage. Saya, also decentralized storage, but we'll skip those for now. If you have a blockchain dApp you're considering building that has a lot of different entities, whether it's widgets or policies or documents or whatever, you can use the entity module. I'm going to skip those for now, and I'm going to give my dApp a name, and we'll call this Ava1. If you are using this for the first time, you're going to see a login dialog, login button here, and you can log in. I typically recommend you log in with GitHub, but it's not necessary. I'm already logged in, so I'm going to hit Create dApp, and what it's going to do is it's going to go ahead and run our background processor. It's an intelligent code processor that we call hypergrep. And what this has done is taken all the choices you've made and generated a full stack application for you on GitHub. So here's the link. Let's go to that. And there it is, generated 15 seconds ago is the full stack application. So let's now take a look at this. So I'm going to go ahead and copy the link. And moving over to the right where I have VS Code running, I'm going to clone this repo. So git clone and hit that. And that's done. So let's go ahead and open up this one here. It's the educated user of, and it's there. So I see that there's already a few questions here. So let me go ahead and answer those before I proceed. So first question I see is, any plans to integrate Arweave? Yes. So we've seen a lot of people ask about that, and we plan on adding that in the near future. Another question is dAppStarter compatible with all EVM chains? In theory, it is, but let me tell you the difference here. You're about to see how we handle the orchestration and make all the work associated with getting started with a blockchain super simple. This includes things like emulator, test account generation, unit tests, compiling, deploying, all of that. So we like to make that effort buttery smooth for developers. And so while the code that we are generating here for EVM, for Ava, the contracts, etc., would work on any EVM compatible blockchain, the tooling and the orchestration we would customize for each blockchain that we decide to add. And the other question is, do you have a MasterChef yield farm option yet? So what you'll find is that our module choices, they are fairly high level and common. What we are working on now is essentially opening up our platform so that developers of all kinds can contribute these modules and extend the platform. So we call that composability. So you'll be able to contribute modules, and other people can then, just like Lego blocks, wire them up together and create their own dApps. So anything you find that's not on here, assume that in the near future, and I'm talking literally in the next month or so, we'll be able to enable other developers to build and plug in. And so someone somewhere is going to find an interest in creating the module you are interested in, and hopefully they'll add it, and then it'll be available for everybody to use. And we are creating an incentive structure for open source developers to build that. So we're really, really excited about that. And I hope you follow us on Twitter and follow our website for news about that. All right, so what I'm going to do here is get going with the developer experience. We like to think that from the time you visit our website to the time you have a working DappStarter app is 15 minutes or less. My fastest time has been 1 minute and 22 seconds. Of course, I'm not talking in a workshop then, just kind of do it. We are also, in the next couple of weeks, releasing containers in the cloud option, and that's going to take that time down to roughly 30 seconds or so, where you don't even need to do what I'm about to do, which is like yarn start and download a lot of dependencies, etc. But let's go ahead and do that. So as a developer working with any kind of package-based solution these days, you are used to typing yarn or npm install, and we use yarn workspaces, which are still not really well supported on npm, so we use yarn. And so this is going to install all the dependencies. So while that happens, I see that there's another question here about any audits on what other devs build and make available through DappStarter. That's such a phenomenal question. I love it. One of the things we are doing as we are extending the DappStarter platform is we are also building a community of validators and auditors, and we want to make it possible for crowdsourced auditing of these modules that are contributed, so that anyone who uses it can be confident in the ability of that smart contract to do what it's going to do reliably and securely. And we are creating an incentive mechanism for auditors there also, and we're also making it better for customers of those modules, the users of those modules, because we are going to essentially provide an insurance layer on there. So this is all coming very soon. You're going to see a rapid evolution of DappStarter, even beyond what we think is pretty amazing stuff right now. But we are going to 10x that in the next few months, and we hope you'll join us for that journey. So right now, Yarn is doing its thing, and it's about to be done, and then it's going to kick off a whole bunch of our orchestration work that you're going to see, and that's what makes DappStarter really magic and saves you a lot of time. Our philosophy is that as a developer using DappStarter, we like to get you to about 80% of the way to your Dapp, and then the 20% of work you do is very specifically on your actual Dapp. Like, what is the core logic, the core features of your Dapp? You do that, and you don't have to worry about, well, which library, which version, which emulator, how do I create test accounts, how do I package, how do I build all this, all of that taken care of for you. You do not have to think about that. And so that allows you to focus. So we use the Lerna package manager, and you'll see that there's multiple packages in here. I'm going to go through those in great detail in the course of this workshop. But right now, it looks like our yarn is done. So I'm going to clear the screen here and kick this off by typing yarn start. Now, when I do this, it is going to do a series of things. For Ava, what we elected to do is, because of its speed, instead of using an emulator, we are going straight with Testnet. So what you're going to see here is live Testnet integration. Now, one downside of that is that if you're working on Testnet and you have test accounts, you need crypto in there in order to be able to pay for the deployment and all that kind of stuff. So we worked very closely with the Avalanche team on that to integrate the faucet also in there. So a faucet request is made, and the test accounts are already are funded. Now, 9.5 out of 10 times, that faucet is going to work reliably and quickly, and you'll get funded, and you won't even know what's happening. But once in a while, the faucet doesn't work as expected, and then your accounts may not get funded, in which case you have to take some extraneous measures, which I'll show you also. But let's see our luck today and see if we can fit into that 9.5 out of 10. So hit yarn start, and DappStarter kicks in. So there's a series of things in this. It's a full stack app. It's got a client UI, a client harness. It's got your contracts. It's got a server API. It's got unit tests, all of that. And all of that is happening here, being compiled. You can see that contracts are being compiled, and it's about to be deployed. Looks like the faucet worked reliably, because as you can see, my wallet was loaded and it's successfully mining and deploying the contract. That is impossible if there is no currency in there. So in that 1 or 2 seconds that I was talking and I did yarn start, the faucet got triggered, and it also went and fetched, got loaded up and compiled and deployed everything. So now the client has kicked in, and what do we know? We have dappiness. So literally, from the time you go to our website to you clone it, you do yarn and yarn start, and you've got a working dapp. Now this is a live dapp working against the testnet with the contracts, etc. So let's start walking through it. But before I do that, let me see if there's any more questions here. There aren't any. That's great. So I will continue. Okay. So what I'd like to do before I go too far is to just demo some of the features that have been created for you before we dive deeper into the architecture and the code. And the best way to demo that is to use our UI harness. So our philosophy with DappStarter is we want to make things as easy for the developer as possible. We know that writing dApps is hard work, and we want you to use all your brain power and all your creativity in actually innovating and building amazing things, and not on things that should be automated. So the UI harness is a great example of that. There's absolutely no reason you should be doing console log and manually writing the code to submit transactions or to get data from the blockchain. So once you've got a contract in DappStarter, which we do now, and it's deployed, which it has been, we should be able to interact with it directly. So for that, we have a UI harness. We have this concept of action cards. So these regions you see here, each of them is an action card, and there's 2 primary kinds of action cards. There's the ones that read from the blockchain, so you see a view button, and there's the ones that write to the blockchain, and you see a submit button. So I started off by saying I'm choosing contract run state because it's a simple one, and you can see here it's trivially simple. So the first thing it has is a check to see, is the contract active, yes or no? So let's do that. And I'll click view, and this actually went to Testnet and queried the contract, and it said, yep, it is in fact active. Now let's go ahead and turn the contract off. So for that, I'm going to submit a transaction. And once that transaction is complete, you'll see it comes back with the result. So usually with an emulator, this happens very, very quickly. But with the testnet, depending on the state of it, sometimes it takes a little longer. than it's doing right now. So let's see what's going on here. Usually when the transaction is completed, you will see a green indicator of that, but it looks like it's taking a little longer than I'd expected. I haven't seen it take this long ever. Looks like the reads are still okay. So let's resubmit that. Sometimes on testnets in particular, transactions are not processed very quickly. So that looks like it's the case here. So I may be spending a little bit of time troubleshooting that as this workshop progresses, but that's okay. I think that for at least for me, workshops are more fun when you run into trouble and you've got to kind of troubleshoot that. But we'll get into that shortly. So going back to the UI harness, I had mentioned that we chose the custom NFT. And so what you have here is a full-fledged and faithful implementation of the ERC 1155 spec. So every function that's there, every read and write is available to you with the UI, so you can play with it directly. One of the unique value propositions of DappStarter is that we generate test accounts for you automatically. And so you can see, in this case, we are generating 6. You can easily change that. If you want a dozen, you can make it a dozen. If you want only 3, you can do that. And it automates generation of that. So this is kind of a quick look at what's happening in terms of the UI. Notice here that I had chosen 2 modules, but I got a third one here called the administrator role. That's because DappStarter is smart. It's actually hypergrep that's smart, and it figures out dependencies and brings them in. So dependent smart contract functions. You're probably used to that with NPM or Yarn, etc. You know, the dependencies are fetched directly, and that's the same here. If you are going to choose something that requires another module, it's going to bring that in. All right, so we'll go ahead and troubleshoot our writing in a little bit, but I want to now take a little bit of time to walk you through the project source code that was emitted for you. And keep in mind that this is custom source code. So if you emit, you make a different series of choices, it's going to emit a completely different source code stack for you. I'd like to start with the most important package we have here in the packages folder, and we call that dapplib. So you can think of dapplib as sort of the heart of your application, of your dApp. It has, among other things, the smart contracts themselves and the unit tests, and also a couple of libraries that are super important. Let's start with the smart contracts. So when DappStarter emits smart contracts, it is essentially weaving together a code from a number of modules and integrating them. The architecture we like to create here is one where there is a smart contract that has all the state data and a secondary contract that calls into this one. And the reason we do that is one of the challenges with blockchains is immutability. And this design pattern here allows you to essentially keep your state in one contract, but have an application with just a logic, which you can manipulate. So if you want to upgrade, you can swap that out with another contract, and the state is not affected, so you don't have to migrate data or anything like that. So that's a good design pattern to follow. It works if you use interfaces. I'm not going to go too deep into that because it's fairly, there's a lot of written material on that. I want to focus on what's special and different about DappStarter. Let's go into DappState here. And one of the things you'll see is that there is a lot of commenting. So we do that deliberately. We kind of over-comment in some cases. We want to make it very easy for a developer to see the origin of any particular line of code. Where specifically did it come from? Which module did it come from? And also what it does. In some cases, like I said, it might be over-commenting, but we'd rather err on the side of doing that than have you try and guess, what is this all about? So the code is written in a very modular fashion for you, but it is custom code. It is not auto-generated by a machine. It is human-generated and then woven together intelligently to create a compilable smart contract. So that's our smart contract right there. And the smart contracts that we emit, because of the orchestration capabilities, are hotwired. What I mean by that is ordinarily, if you change a smart contract, you're going to need to recompile it, and you're going to need to redeploy it. But in the case of DappStarter, you make a change in your smart contract. I just put a space there, and I hit Command S to save it. And in a second or so, the hot wiring will kick in, and it will deploy it. So that's the smart contracts. Now let's take, and you can see there that it just recompiled and is going to redeploy here shortly. All right. So in addition to the contracts, within this folder, you're going to find a source folder with some JavaScript. And this is super important. And I want to spend a little bit of time in this folder because it is really how DappStarter works and makes things simple for you. What I'm going to do is start off with this file here called dapplib. So dapplib is basically a JavaScript class which is a one-to-one with every function that exists in your contract. So here we've got a read for is contract run state active and a set contract run state. And so we'll find those two functions right here. We've got an is contract run state that's reading, and then we've got a set contract run state. So at this point, in order to make things a little easier to understand, I'm going to bring up my slide deck again, because I've got a couple of pictures that's going to help you understand how dapplib works and a few other things. So I'm going to go there and then come right back to the source code. So let's do that. All right. So this is the virtual look at the DappStarter workspace. I'm probably going to go back and forth a little bit as I explain each package. But right now we're talking about dapplib. And as I mentioned and showed you, it has all the contracts. And the file we are looking at is specifically the DApp library. And in addition to that, there is something we call the blockchain proxy, and we have the unit tests. Now, to explain the blockchain proxy, let's look at this architecture here. I'm going to explain some of this other stuff in a bit, but I'd like to focus your attention on the bottom here, the green boxes. So the way we've architected rather DappStarter is that we have the blockchain layer here. The contracts are specific to a blockchain. Of course, if the blockchain is EVM compatible, then the contracts are all the same. But we look at the blockchain proxy as the dividing line between a blockchain and the rest of DappStarter. So blockchain proxy is essentially a JavaScript class that abstracts everything specific to a particular blockchain, however it interacts, whatever libraries it uses, whether it's specific to Avalanche or if it's Ethereum, etc. We take those libraries and we have a dependency within blockchain proxy and nowhere else in the whole application. Now, in blockchain proxy, we have this philosophy that we want to make DappStarter highly compatible and highly understandable by Web 2 developers. So we take the concept of REST, which has get and post verbs, and bring them to blockchain. So in blockchain proxy, for every read of the blockchain, there is a wrapper function called a get. And for every write, there is a post. And there's also an event generation kind of capability. So with that understanding, you can see that in dapplib, which calls into blockchain, everything is either a get or a post. It's that simple. Once you've got DappStarter going, your primary work is going to be in modifying contracts and modifying dapplib. You do nothing with regard to interacting with the blockchain, things like gas, how you structure your inputs, all of that. It's all managed for you I'd like to call it a light opinionated way, because you're free to change that if you don't like it, but it has some opinion. So let's go ahead and now, having that context, look at this here, and you can see that this is super formulaic. It's saying await blockchain.get. So that's your key that this is a read to the blockchain. And then this particular one here is saying blockchain.post. And it's obviously going to write to the blockchain. And you can see that the functions and how they are organized are very, very similar. So we pass a configuration. So what this is doing is dynamically retrieving all the connectivity parameters that are required, what is the contract that is going to be interacted with, what is the specific method that is going to be interacted with, what are some of the parameters and things like that. So this is a dapplib, and it's calling into blockchain. Blockchain does all the heavy lifting of interacting with it. Now, having seen this, let's move up the stack a little bit. I mentioned earlier that there are unit tests. So if you go into the test folder, you will see that for every module that you use, there is also a specific unit test script that's created. Now, we are using Truffle under the hood. We are planning on having a hard hat variant also soon, but for right now, it's Truffle. And for each of these, we've created all the unit tests. And one of the most interesting things you'll see is that in a typical blockchain app, you will have to write those unit tests from scratch, including all the interactions with the blockchain, etc. But because of the architecture of DappStarter, with dapplib being present, your unit tests also can just take advantage of dapplib. So it's doing double duty. It's saving you time because you don't have to write all that over again. But more importantly, it's testing your stack, including your dapplib logic and your smart contract logic all in one place. So Truffle by default uses the Mocha test framework and the Chai assertion framework. And that's what we have going on here. So all these tests are written for you. You can copy paste and modify them as much as you wish. But again, the most important thing to understand here is because they are calling into dapplib, you're really just arranging, if you think about traditional testing patterns, you do a lot of the arrange, but a lot of the assertion aspect of you is pretty straightforward because you call into dapplib, get a result, and test and assert if that result is what you expect it to be. So all of this is set up for you also. Let's look at a couple more things of interest here. So within dapplib, I had mentioned very early on that there is a faucet and compilation and deployment is automatically handled. So if you want to poke around in here, you can see those scripts. There's the faucet script that actually calls the API and requests funds into the test account. You can tinker with that if you wish. And there's a deploy script here that is actually doing all the deployment, including dependent contracts and so on. Now, one interesting thing that happens is you're seeing this file here in green, dappconfig.json. It's green because Visual Studio Code is indicating that it's modified. In fact, it's a brand new file because it's auto-generated for us. Every time you run yarn start, it is going to go ahead and generate test accounts for you. It is going to reset everything because it's recompiling and redeploying the smart contracts. And that's where dappconfig comes into play. Within dappconfig, what we do is we write out the current address of the deployed contract. We auto-generate accounts for you, and we also auto-generate wallets for you, which is essentially the account with the public and the private key. And they are written in here. Now, one of the things that you have not heard me mention yet is integration with the wallet, etc. And that is also a part of our philosophy with DappStarter. We find that again and again, when we go to tutorials, etc., on blockchain app development, they start with, well, get a wallet, create an account, etc. And by the time you get to the exciting part, which is writing code, most new developers have already zoned out because the level of complexity of dealing with crypto, understanding public private key, encryption, etc. It's a cognitive load that's too high for someone just coming into web. So we decided we're going to flip the whole model over. Instead of having you think about wallets and all that at the onset, we'll let you think about it later once you're more comfortable and you've actually got something worthwhile that needs to be deployed and you want wallet interaction with it. So until that happens, dappconfig.json is your wallet. Things in blockchain, code in blockchain.js auto-signs using the wallet you choose, and you don't think about it. We'd like to have you start thinking about it when you actually got something meaningful, an application that's meaningful, and we don't want the wallet stuff to get in your way. Now, some of you might disagree with that philosophy, and we're happy to hear feedback on that. But in terms of teaching developers how to code, helping them learn, this is what I have learned from many, many years of doing that. I was the primary author and instructor of Udacity's blockchain nano degree, and thousands of developers have learned Solidity from those lessons. And what I've done is with our team here is build into DappStarter all the learning of how can you get from zero to being a dApp developer as fast as possible. And that's what the opinionated part of our DappStarter is. So dappconfig.json, as I mentioned, auto-generated. You don't have to worry about it. You don't have to think about it. It just happens and works. And you can see here that the URL it's working against is the Ava test network. You can certainly change that. If you decide to run the Docker client and run on the emulator locally, you can change that to localhost and work with it that way. All right, so that's all blockchain, dApp config, etc. A quick peek at blockchain JS here. You can see it's got its get, post, etc. You don't need to do anything with this. It's available for you to tinker with if you wish, but dapplib is what you tinker with. That's where you make your changes. And if you add, for example, a function to your contract, you need to come and add, you don't need to, but you should come and add a wrapper function here to call into the dApp, into the smart contract. Now, one thing you'll notice is that pretty much everything here is static and async. That's another important design pattern we follow. We don't want to have these JavaScript classes which are heavy and burdened and have to maintain state, etc. Blockchains and dApps are stateless, and we want to emulate that in our code in JavaScript. So every single time you call a dapplib function, it's going to go and fetch what is the configuration. It's going to enumerate that and it's going to figure out what it needs to do. It's a fire and forget thing. The next time it's going to do that again. So it's all asynchronous and it's all static for that particular reason. Again, this is about lowering the cognitive load for you as a developer. Don't think about, well, what class is it? What, do I have an instance of it? How do I initialize it? All of that. You don't have to worry about that. There's another helpful feature here. You notice that all these functions just have one input, it's data. So we presume that your contracts are going to have a variable number of input parameters. They may be different types, etc. We wanted this to be formulaic. So what you do is you handle that in the upstream UI, which you're going to see in just a moment, and always pass just one object to your dapplib, and that object should be hydrated with all the properties that are expected to be found when the contract function is called. All right, so that's all dapplib and blockchain.js, and also the faucet, deploy, etc. By the way, if you look in package.json, you can see that we've got a helper scripts here, so you can do like a yarn faucet, a yarn deploy, a yarn test, etc., and execute some of those. All right, I'll pause here for a moment to see if anyone has any questions. No questions thus far. Great. So we are doing quite well. We're doing good on time also. So let's go ahead and continue now to our next package, which is the client package. So everything you see here is coming from the client package. Speaking of the client, let's probe into that a bit and see what's going on. So you can see this dark blue, almost navy border around here. We call that our workspace, the DappStarter workspace. And we have that primarily for your convenience. It is not necessary. It is not required. All it does is wrap all the tools together. If you want to look at your Dapp homepage or you want to look at the UI harness separate from the workspace, it's available to you with this arrow. You can pop it open and you can see that each of these is actually running on a different port. So we have the client, we have the server, etc., running on different ports. So as a convenience, we provide this workspace frame, but you are not required to use it. So the client is essentially combined into multiple parts. The main part is your homepage here, with the one that says dappiness. That's the one you'll be manipulating. But we thought it would be useful to have the UI harness, etc., also available to you until you're ready, at which point you can just get rid of it. So let's go into client and look at those. So we use the Tailwind CSS framework, and earlier in this particular stage, I had to choose my JavaScript frameworks. There's JavaScript and React. I will say though that even though we have React there, it's technically React Superlight. We took the stance very early on to do everything we do as web components, to make them mostly agnostic. So you can use Vue, you can use Angular, you can use whatever you want. It's really highly unopinionated because it's web components, and you can weave your client app however you want. So let's look at some of those client components and see what's up with those. So a good thing for us to do is to first take an overarching view of the client and how it works. One of the challenges once you get past the smart contract and you get into the client is you got to find a good skeleton. You got to, or a boilerplate. You got to wire up Webpack and Babel and all of those things, etc. Well, guess what? With DappStarter, don't need to do anything. It's all done for you. And I'll demonstrate that by going to the UI harness here. And you can see that I've got this UI harness code here. Let's go into one of these. So this is contract run state. So this is the code for contract run state. You can see that there are these @ elements here. So we decided early on that we wanted full color highlighting, and we wanted to make it super simple for developers to create the web components. And so for that, we decided to use a library that's very popular called lit element. So lit element is one of those libraries where you can use a very little of it and be happy, or you can use lots of it and be happier. So we decided to go with the light approach and use small aspects of lit element that made life easier for the developers. For example, this is a web component, and we wanted you to be able to easily define properties. And you can see here that lit element allows you to essentially use the @ notation to distribute to define properties, attributes, and that's cool. In the render here, you can see that lit element does color highlighting for the HTML. This is unique and interesting and exciting, because otherwise you would see a giant gray blob here, because this is a JavaScript templatized string, and that would be really hard to work with. But we want to make it easy, and so lit element is what you have. So this component here, as I mentioned, is set up to be hot loaded, and it uses Webpack. So let's go ahead and make a tiny change in this contract here. Let's go. Oh, sorry, I called it a contract component is what I meant to say. And hit save, and you can see that it immediately compiles, deploys, and on the left side, it's done. So you can almost interactively build your client for your contract. Now, here's the beautiful part. Remember we talked about dapplib quite at length? Well, these components also rely heavily on dapplib. And so if you've got your dapplib functions well written, you're good to go. Anyone can create any kind of web client. And if you look at the makeup here, the dapplib is a whole separate library. It is actually compiled as a separate library. And the reason for that is if you want to, for example, create a mobile app with React Native, you can use dapplib and it'll work just fine. So not only can you build web apps, but you can build native mobile apps also using DappStarter very easily because of this level of abstraction that is present. Okay, so we're looking at these UI harnesses here. And as I mentioned to you at the onset, we tried to make every read and write available to you. And the way we do that is with these action cards. So an action card is a built-in component in DappStarter that makes it very, very trivially simple for you to interact with the blockchain. And the way an action card works is, as a web component, it has a few properties. The properties are fairly self-explanatory: the title of it, the description of it, and the action of it. So the action is literally the name of the dapplib function it should call. So, and then the method is get or post. So the reason you have that method is to indicate in this action card whether to show a view button or a submit button. That's really all the method does, because in dapplib, the actual code for this method already is prescriptive. It says blockchain.get, so it doesn't need to do that. All this is doing is indicating to you what button to put a get or a view or a submit. Now, the view is fairly self-explanatory. It doesn't have to pass any data. But how do you pass data to an action card that has multiple inputs? So this one is fairly simplistic. So let's start with that, but then let's go on to something more complicated. So you see here in this particular action card, in addition to the 4 attributes I have up here, I have one more called fields. So the way this works is you can define any number of nested components, web components. And so we have a bunch of them called widgets, or you can even do native HTML components. And it's going to take, in the case of our native component, a field attribute, or in the case of an HTML attribute, a data-field attribute. And whatever name it has, you add that on here. You tack it on here as a list, and the data will automatically be passed. Let me show you an example of one of these, the custom NFT harness, and that will make more sense here. So here it says fields should be authorized and new URI. Let's actually go here and look at that. So this is the set URI one. So it has 2 fields. It's got a dropdown for selecting an account. So that's our account widget. It makes it super simple for you to have any place you need an account. You put the account widget while you're developing. Later on, you actually get that from the wallet. But during development, you don't have to worry about it. These are all the test accounts. It hydrates them automatically. It even puts funky names here. So you can use names instead of saying 0xD6 or whatever when you're thinking about these. And then there is the a field for the input. So 2 fields here. And you can see that this one says authorized and this one says new URI. And sure enough, in my fields here, those 2 values are space separated and put in there. So action card makes it that simple for you to interact with the blockchain. It just throws up the UI. And this is designed to be super, super portable. So going back to my run state here, let's say I want this action card in my homepage. I want to actually use it as is. We don't expect that you will, because you'll want to create like a real friendly UI for your dApp. But say you want that. What would you do? Well, you would grab this action card and you would go to the code for this page. And that is right here in index.js. Oops, sorry, it's wrong place. dapp.js is what it is. I misspoke there, sorry, under pages. And you can see here that this has the dappiness word, etc., and it's got a bunch of code, whatever you're seeing there. Let's get rid of that. And let's get rid of this also. And just drop in our action card here, which got slightly malformed, but it's okay. And save it. So it recompiled, and there we go. And it should still work, and it still does. So you can see that makes interaction and building out your app also super simple, because you can borrow from the UI harness and then modify it. Like I said, we don't expect you to use the action card. But here's the beauty of it. This button that I referred to earlier, it's in fact its own web component, and it's available to you as an action button. So even if you decide to create a more sophisticated UI, you can still take advantage of the ease of use of that, because the action button is actually the one that's being passed the fields, the post, all of that kind of stuff. Action card is merely a glorified input wrapper for the action button. So if you start using the action buttons in your UI, you can style them however you want, and you can have whatever grids, etc. you want, whatever Tailwind supports, and it supports a lot. You can create that kind of UI. All right, so I'll pause again here and see if there's any other questions. Nope, there aren't. So I must be doing either a great job or a terrible job. I guess we'll find out. All right, so that's DApp, the UI for you. I just want to run through some of the other UI harness pieces here and show you some of the code and also some of the interaction pieces. So I mentioned here that this was the simple kind of module, and our submit wasn't working, so we should troubleshoot that. Actually, this might be a good time. I want to troubleshoot that before I go any further. So we still don't have. Now, typically, if this was an emulator, I would have a lot of diagnostic feedback I could use. But unfortunately, when you're going against Testnet, we can't do that. All right, so this looks like it's got a fairly straightforward JavaScript error. That is in blockchain.js, and here we go. So it's saying the transaction is underpriced. So that refers to the gas price that is being submitted. So I actually encountered this error yesterday, and I thought I fixed it, and I think I did fix it for the deployment of code, but I did not fix it in DappStarter for the contract. So this is a great opportunity for us to dive into and fix that. So this change happened, I'm going to guess, very recently in the Ava blockchain, where it seems like the gas requirement has gone slightly higher than what it was. So earlier this morning, in fact, I fixed DappStarter and updated specifically in Truffle config the default amount of gas that is used with each transaction, but that appears not to be enough. So let's go ahead and see if we need to update that, and hopefully we'll be successful in fixing that. So over here, you can see that. Let me just close this so it's easier to see. So I am now deep in the innards of DappStarter in blockchain.js. As I mentioned, you shouldn't be changing this. Once I figure this bug out, I'll go ahead and change it in DappStarter, so the next time you generate a project, it'll be fixed. But you can see what's going on here is that we are reading the current gas value, and we are also reading the current gas price. Now, what I found out earlier today in the change I made to Truffle was if I passed the gas price, it was not working. So let's try a simple fix here. Let's just comment out gas price and see if that'll fix the problem. Because if that does, then great, we can move on with life. So that's recompiling and redeploying. So let's go ahead and submit our transaction now and see if that helped any. I should probably look at the console. So it looks like it still says it's underpriced, and it says the gas price is this value here. So for the sake of expediency, let me just grab this value, and instead of removing it, hard code it. And what we'll do is we'll put it in here, and it's going to be a string, and it'll be converted to hex. There. I think that should take care of it. Let me just check and make sure that that is in fact a string and not a number that an integer. So give me 1 second. We'll check that out. Oh, that looks like it should be a number. So I should actually make it a number. All right. So with that done, let's try this again. And I'll give this a couple more tries. And if I can't fix it, I don't want to take up too much of your time, but I will definitely fix it offline. so that when you do generate, this gas problem will be gone. I apologize for that. It's something, like I said, I just found very close to this session and didn't get a chance to. Oh, there we go. That did fix it. So great. So now you can see that it was a gas price problem, and I'll make that change in the actual code, and when you generate, it'll work. But now you can see that the transaction went to the blockchain and it did get completed. And how can you tell that? Well, there's a transaction hash here, and there's one more way to verify. We'll do that first and then go. If I do view here, it should say run state active no. That's because I turned it off. Let's go to avascan .info, and let's go ahead and paste that transaction ID in here and hit enter. And oops, I forgot. I always do this. I forget to switch. So we are on testnet. We should switch to the Fuji testnet first. So that, and then hit enter, and bam, there you go. You can see a live transaction result right there on the blockchain. You can see exactly, it was a minute ago. So you can see what happened, what was in the execution tree, etc. So this is a phenomenal way for you to actually build an application in real time. You can modify your code, it hot loads, it redeploys, and you can actually get these transaction values and check them out and verify for yourself that things are happening the way they are. Now, I've turned my contract off. I don't want that. I want it to work. So let's go ahead and turn it back on again, which is going to fire up another transaction. So let's do that. And that's completed. And if you check again, you'll see that it says yes. Now, this also gives me a chance to demonstrate to you a usability feature. Let's call it a DX feature, developer experience feature we have here. In most environments, when you're testing out a UI or something like that, every time the page refreshes, things go away. In things like the JavaScript console, etc., you can check a box that says persist. And that's useful because sometimes you want to see a trend, you want to keep a track of what you've done, a history. And we did that just like this. So the older results fade away, but the most current one is still there. And you can get rid of them when you're ready for it, but it's there for you. It's there to help you go through the development cycle, make the changes, and see states. And again, I keep using this term, but it's important. Reduce the cognitive load on the developer's mind so that they can be focused on actually doing meaningful things. So that's what DappStarter is all about. So I do see a question here. Amazing stuff so far. Presentation is great. Thank you. Appreciate that. But what's our business model? How do you guys make money and the license used? That's an excellent question. So all of this is 100% free. It is going to be 100% free. You pay nothing for all of this kind of stuff. I mentioned earlier that we are building this network, or this registry rather, of composable modules. So we are essentially evolving our business to a DAO model, and we'll make money when developers build smart contracts, deploy them on here, and for that every transaction, when a developer makes some money, we make some money also. So we take a small piece of that. That's it. So there's no fees, there's no subscriptions, none of that. It's just completely a decentralized, modern, open source monetization model. That's kind of where we are. So hopefully I answered your question on that. We are currently venture funded, and we will be for the foreseeable future. That's our source of capital. And some of the L1 chains also provide some of the funding for integration, but that's a one-time thing. But as a developer, you pay nothing. All right. So now that we have gone and seen how this really basic module works, let's look at a more exciting module. I think by now I've covered everything there is to cover in terms of the stack. Let me just pop up my slide here and make sure that I've done that. I don't want to have missed out on anything. Yeah, I think I've covered everything. And here now, actually, this picture makes a lot of sense. Hopefully to you, you can see how there are web components, there's action cards. An action card encompasses an action button. There are widgets to help with the UI. All of this is totally optional. In fact, our whole client is totally optional. Just delete it, throw it away, don't use it, go bring your own scaffold, your own boilerplate. All you got to do is make one dependency, import dapplib, and you're good to go. So all of this is there for you to use, to borrow, do whatever you want to. Don't use it if you don't like it. It's not opinionated. I'm not going to spend a lot of time talking about Nest.js here, but suffice to say that we also have an API. I'll just quickly demonstrate that to you, but we won't be going too deep into it. So with all these functions that are there, we've also integrated a Swagger API UI for you so that, again, as you can imagine, it calls into dapplib. And so if you want to have an API, potentially, that's behind a firewall in order to do some admin type functions, etc., we've got that support for you also. So there's the API. It called the run state function. It returned true, and it just worked. You can also extend that as you wish, and that's in the server here. I don't talk about that too much because you have to be at an advanced state building a really large-scale dApp that has admin functions and all that before you really need server. You may also need it if you want to capture events. So one of the things that the server does, the server modules do, is they capture all the events that are emitted in your smart contract. So you could potentially maybe write to your own Web 2.0 database log or something like that if you want to. So it's all optional. It's there if you want to use it. But going back to the heart of this, so with the UI harness, now let's go into our custom NFT module. So as I mentioned, this faithfully implements the ERC 1155 spec with a little bit of fairy dust or dApp dust, whatever you want to call it, of our own in there to make things slightly more exciting and interesting. So the first thing that 1155 requires is for you to set a general URI for all the NFTs that will be minted here. So you can put anything you want here. I'll just call it my NFT.xxx or something like that. And we'll hit submit. That's going to trigger up our transaction. And that's done. And now we can check that the contract has that reflected. And sure enough, it does. It wrote that out. Great. There's a lot of ERC 1155 functions here. I'm not going to go through all of them, but I am going to talk about them a little bit. So for those of you who are not familiar with ERC 1155 NFT smart contracts, they are hybrid contracts. They support both fungible and non-fungible tokens. So you can mint different classes of tokens here, and you can actually mint NFTs also. So what we decided to do is give you the ability to have this single module, which is the NFT, the custom NFT module, have an architecture for different styles of NFTs. So you can see here that out of the box, we've got this mint serial NFT. Let's go ahead and look at the contract source code for that. And that's right here. And if we go and look at the fields for that, let's collapse this a bit so it's easier to see. There's the administrator role, and there we go. So we've got metadata here. Give me a moment. Gotta find the right place for this. I should just search for serial, actually. It should be easier. Oops, you know what? I apologize. I'm looking in the wrong place, in the wrong contract. So that will be right. I seem to have missed something here. Bear with me. Oh, it's in generator.sol. All right. So I was looking in the wrong place because I forgot that this is actually an imported module and not there. All right. So right here in dApp state, I was in the right place. Sometimes I get flummoxed because we have so many different modules and so many architectures sometimes. So you can see this import here. It's importing generator.sol. So let's go look at that. So in here is generator.sol. And you can see that it has metadata, uint 256 serial. So the thing that makes NFTs unique within a contract, other than the fact that they have a different ID, is the metadata. Metadata is where you store the descriptive attributes about your NFT, anything qualitative, anything quantitative, but most importantly, more than likely, a hash pointing to, let's say that it's a picture or a video. You're going to store it in IPFS, and the hash is what's going to get stored into the actual contract, because you can't store media in the smart contract. It's too cost prohibitive to do that. So what we have here is an architecture where you can easily swap out the metadata with different models based upon the type of NFT you are creating. So with the default, it is drop dead boring. Your ID, your NFT has an ID and it has a number, a uint 256. Yes, you can create an NFT app like that and probably meaningful in some context, but quite boring, you have to admit. So what would a meaningful NFT dApp look like? Well, for that, what we've got is this little feature here called Customizer. This is a relatively new feature for us, which is also one of the reasons why I didn't jump to the generator Sol right away. It is kind of something that's evolving very rapidly. So if I go to Customizer, what you'll see here is every module that has a customizable feature, a dynamic customizable feature. In here, when you're customizing the project, that's static customization. That code is emitted into the GitHub repo that's created for you, and it's done. It's not going to change. This custom is modifying the code in place within your project as you're working on it under your control, which is a cool thing. So right now, with custom NFT, we only have 2 capabilities, but we're going to add a bunch more. So as you can see, it's still in beta. We don't even have the pretty pictures and all that yet. I apologize for that, but it does work. So with serial, you've got an NFT with auto-incrementing serial number. Fine, you've seen that. But we can switch this to this thing called Mongram. So this is a little library I wrote that does generative art. Let me show you what that is. So one of my favorite painters is the Dutch artist Mondrian. And what I did was I created generative art JavaScript code based upon his work. So that's at mondgram.com/demo.html. I should probably just paste that in the chat so everyone can go look at it. All right. So it doesn't work on mobile. I'm aware of that. So if you're on mobile, it's not going to work too well. All right. So let's choose count 10. Let's do scale of 3. Keep white, red, blue, yellow, and hit generate. And you can see here that once you see this artwork, you probably realize it's familiar to you. So this is a generative art code for taking that concept of colored regions and rendering them dynamically. And you can choose the color palette you want, and it'll generate different color palette, etc. But what I'm going to do is I'm going to draw your attention. It's kind of small, so let's zoom in a bit. I'm going to draw your attention to this little string here. So the code uses what I would like to call a genomic algorithm. So just like the human DNA is a string that defines your characteristics, and although like 99.5%, it's all the same, the little bit that's varying makes us who we are and defines our characteristics. So this is that kind of thing where this string here actually implements the entire design, not as an encoded thing, but the rules of how this should be created, which rectangle goes where, and what it should be colored, and so on and so forth. So this is a very trivial, almost simplistic example of generative art. I'd encourage you to check out this next library we are going to integrate. It's called Chromata JS. We'll be incorporating that also soon. I'll show you a quick demo. But what it does is it will take any uploaded image and it will render using different JavaScript algorithms generative art from it. So you can see the different styles, etc. So this is a great NFT app to build where the user uploads a picture and you use the generative art capabilities to create awesome things. So we'll add this also as one of the options in the composer. But for right now, you have Serial and you have this monogram, and both of those give you an example of how to create an ultra basic NFT and then something a little more sophisticated. So going back here now, I mentioned to you that this is totally dynamic. And so notice here, when I go into this module here, this UI says mint serial NFT, etc. Let's go to the customizer and hit update project. And you can see that a few things happened. My generator code changed. So now, instead of just a uint with one number, I've got scale, I've got mDNA, so that's the monogram DNA, and the color. And going back to my UI test harness now, you can see that, oops, that did, oh, I have to reload that, sorry. So one of the things, I said this is in beta, one of the things that this does not do yet is automatically restart this. So I do have to do yarn start here, and I apologize, I should have mentioned that. So this feature is a really cool feature, but we're still working out some of the rough edges. So give it a moment here, it'll recompile, and you'll see the UI has changed. Excuse me. And there we go. So now we have a different UI, and we are basically creating for the user the ability, oh, it's not done deploying yet. That's why it reloaded. So it's still waiting for the contract to redeploy. It might reload one more time. Oh, it looks like we're done. Okay, so now instead of just generating a number, you could have the user generate generative art, in this case, a monogram. You can allow them to preview it and say, what did you get this time? So this is a random thing, right? So every time they hit preview, they would generate a random one. Of course, you would not want to do this. You won't want to mint this perhaps on a server and then submit it to them, or you would let them click once and they get what they get, because otherwise the user is going to click forever and try and get something that has a higher rarity or more aesthetic value. Now, of course, if that's what you want them to do, this is a great feature. You can let them click around until they get something, that they really, really love. And then when they're done, then it gets minted. Obviously, you would not have the user actually, enter the ID and things like that. This is computation. In the UI harness, we give you access to all those fields so that you can see how to do that, what is going to be in the UI for the user, what is going to be computed in code. I'll point out that as this was built and switched out, dapplib.js was also updated, and so it has all the code. So let's go find that. There we go, NFT Composer. It's got actually that will also be imported. So I'm not going to waste your time looking for it, but you can see from the UI that it's actually there. But in dapplib, it's been updated. The contract has been updated with the code to be able to persist this, and you can hit submit, and it'll actually do that. It'll generate a transaction and save that there to the smart contract with the DNA for this particular thing. All right, so it's coming up on 4:15 Pacific here. We're almost to the end of this this demo. I think I've showed everything there is to see in DappStarter. There's a few more layers that we could go into, but I think all the key components I've covered. Let me just go back to my slide deck and make sure I haven't missed anything here. Yeah, that's pretty much it. So I'm going to go back into the code and just do a once over on it. But before I do that, could you kindly take a moment and join our Discord community? This is where you can give us suggestions, give us feedback, etc. And tell us how we are doing. Tell us what you would like to see. So we'd love for you to be a member of our community. In particular, as we are rolling out some of these announcements about the registry and about how we are expanding, our platform, our Discord community and our Twitter is where we are going to make a lot of those announcements first. So if you're there, you can even participate in betas and things like that. So we look forward to that. All right, so back here, a quick glance and walk through here. I think we've covered everything. Oh, you're probably wondering, what is this workspace thing here? So that's just the frame around here. You can safely ignore it. In fact, for most people, I tell them, don't even bother opening that. There's nothing useful there. You could probably just break a few things, but if you're the tinkering kind, you're probably going to go look in there anyway, so it's fine. All right, so that is DappStarter. I hope you enjoyed this demo. I hope you'll go and use DappStarter. Again, it's dappstarter.decentology.com. I'd love to hear feedback about your experience. You can either come to our community on Discord, that's discord.gg/Decentology, or you can ping me on Twitter @techbubble. Love to hear your feedback. If you have any problems, our team loves to help developers. We'll answer your questions and get you unblocked with whatever is causing a block. If there's a bug you find, let us know. We are very responsive and can deploy a fix right away. Like, for example, that fix I showed you, it'll be up there by tonight. So if you generate after tonight, you will get the fix there. All right, so I'm going to pause here one more time and see if there is any more questions. Right, that looks like it's it. So Rocky, I'm going to turn it back over to you and see if you have any questions or observations or comments you'd like to make.
No, that was fantastic, Nick. Thank you again. I love just the scrappiness, the live debugging. I'm sure everyone super appreciated that.
Yeah.
And yeah, it was kind of interesting that actually specific bug will actually be changing because that our gas fee is set on Avalanche. We're kind of unlike a lot of the other chains. So right now it's a set gas fee. Going forward, we do have dynamic fees on our roadmap. So you'll start to see it. It'll be more like, an Ethereum base where, depending on the demand on the network, it'll change, as needed. But yeah,
good to know. I'm glad we actually found that bug and were able to play with it, because that's great information to have. Thank you.
Yeah, absolutely. I mean, you found it within a minute and got it taken care of. So no problem at all. Yeah, so unless there's any other questions, I don't see any. Nick, I want to thank you again, you and Chase and the rest of the Decentology team. Thank you guys. We loved having you, very informative. And for all those in the audience, Nick, would you say Discord is probably the best place for them to find you?
Yep, discord.gg/Decentology.
Awesome. And for us on the Avalanche side, we tend to push people to our Twitter. That's our sort of biggest following. We also have a Discord and some other assets, but yeah, follow us on Twitter. And yeah, this was great, Nick. Again, want to thank you and the team. And we hope to actually have you guys back maybe in 6 months once you have sort of more features. We'd love to get an update there in the next several months, and we'll see what you guys have done.
Great. Thank you so much, Rocky. Have a wonderful day. And thanks everyone for attending. Appreciate the opportunity to show you this. Thanks.
You bet, Nick. We'll talk soon. Thank you again. Thanks, everybody.
Thank you.
Bye-bye.